live. And starting the webinar.
Okay, so good evening, everyone. Welcome to this live stream session of OWASP chapter meeting. This one is live streamed on YouTube, and also you're available to join on Zoom to actually ask questions directly to our speaker. I would like to thank Maxim for setting up the whole infrastructure to actually being able to stream this session and to record this session, and also Steve Springett to be joining us today. He will be talking about component analysis and dependency tracking. But before we go in that direction and go a little bit deeper, let me also give you the information that this is actually one of many virtual chapter meetings that we had already in 2021. And all of those can you actually view on YouTube as well. So if you missed one because you were on holiday or you didn't have time, don't worry, you can actually look them up in the OWASP.be website and also go to the YouTube channel to actually find the right one and follow the stream. For today, we have a live stream, but I also have good news. We don't stay to the live streams anymore. We're also trying to actually organize a physical event. The end of November, we actually will meet in Bruges here in Belgium with the OWASP Benelux conference. The venue is casted. Now we are actually selecting the speakers. And if you go to owasbenelux.eu, you will actually see the program growing in the next few days, the next few weeks. So in that sense, we hope to welcome you all physically end of November. Let's hope that the situation stays good so that we actually can meet. But for now, we are actually staying with the virtual information via our chapter meetings. If you want to follow what we are doing live and online, you can follow many of the channels like YouTube, the Meetup, the LinkedIn, and also Twitter. Also visit OWASP.be to actually go to the OWASP website to see what information is available on next chapter meetings. For today, we have Steve Springett here with us. Steve is passionate about helping organizations to identify and reduce risks incurred from third-party and open source components and libraries. He's also the lead of 2 flagship projects working on dependency tracking and also the Cyclone software bill of materials, and also involved in the SCVS project. So I would like to give him the floor to explain much more about the 3 projects he's discussing, he's leading as well in OWASP. Thank you, Steve, for being present here, and you can take the screen.
Very good. Yeah, thanks for the invite. I'm happy to be here. Let me see if I can share here. Yeah, I'm pleased to be here. I wish it was in person. I love Belgium. I can't wait till I can go back for sure. But thank you all for joining me. I'm going to be talking about component analysis today. This is not a talk that I've actually done before, so you're the first. We'll see how it goes. But it is based on a lot of the other material that I have spoken about in the past, just presented in a little bit different way. So so hopefully it'll be a little bit more relatable. Anyway, as was mentioned, I do a lot of things in the OWASP community. I lead 2 flagship OWASP projects, including OWASP Dependency Track, as well as OWASP Cyclone DX, which is a software bill of materials standard. There's an incubator project, although it's still highly visible. It's actually referenced by NIST multiple times, the OWASP Software Component Verification Standard, as well as a bunch of other things in the supply chain space. What I actually get paid to do is software security architecture at ServiceNow, where I lead a team of architects, and we're helping the company to build secure and resilient software. So let's step back for a moment and kind of define what is SCA, right? We all kind of have our ideas of what we think SCA is or what it should do. This is a definition from Synopsys's website. I'll let you read this, but it's interesting that they reference security, license compliance, and code quality. Not sure I agree with the code quality aspects, but okay. That's a definition of SCA that I think we all can mostly agree on. And this is kind of what we're all used to, right? We scan things, we identify if that component has known vulnerabilities, if it has any license compliance issues, and that's kind of what SCA does. This is the typical capabilities that your SCA products in the market will typically have. So again, vulnerability analysis, checking whether or not the component is out of date or not, license compliance and evaluation, and then some SCA products also have a policy engine that allows you to evaluate and then optionally enforce policy in your build pipelines, for example. And that's typically what SCA products do. They all offer certain things, whether it's a more robust policy engine with the ability to do policy evaluations on different types of data, or whether it's the data from the provider itself, from the vendor itself, might be a little bit more richer. They all kind of bring certain capabilities to the table that differentiate themselves from the other vendors in the SCA space. But is this really all that we care about? And if not, then what else should I care about? So today I'm going to step back a little bit, and instead of talking specifically about known vulnerabilities and license and outdated components, which are all important, right? Mind you, this is not a BAS session on SCA. What we're trying to do in this talk is really kind of reset and look at the bigger picture. And SCA is an important part of that picture, but it's not the full picture. So today we're going to be talking about component analysis, which on purpose is a pretty vague term, because what we've kind of defined the component analysis as is this, and this is taken from the OWASP website on component analysis. Notice we are referencing both software and hardware components, and we are talking about a much broader range of things than SCA. I think component analysis, if you were to look at the big picture, is a superset of SCA. And that's kind of how we're going to frame this discussion going forward. So what is component analysis, and what other things should I care about? Well, number one, and this might be obvious, but it's actually quite difficult, is to describe a complete and accurate inventory. Well, you might ask yourself, hey, my SCA product does this. Actually, no, it doesn't. SCA products are not designed to have an accurate inventory. They're designed to identify risk. And if an SCA product identifies a version of a library, but the version matching wasn't quite right, usually it's good enough, right? Because if they're one minor version off or whatever, it's usually good enough because that component is probably still affected. But it's not an accurate inventory. At my own employer, we use multiple SCA products, and none of them are accurate, right? There's varying degrees of accuracy. The most accurate that we've ever been able to achieve on any SCA product is roughly around 90%. So that means 10% of my inventory from the SCA products that I use is inaccurate, which is an interesting number. I would highly encourage you to perform this own research in your own respective organizations, because identifying a complete and accurate inventory is actually kind of hard. Now, what do we mean by complete? Well, complete is nuanced. It really depends on what it is that we're delivering to the market. If we're delivering a microservice, well, it's probably just that service along with the libraries that it relies on. But that microservice probably doesn't live in a bubble. It probably has a dependency on other services, which should probably also be captured. Now, if I'm delivering an IoT toaster to the market, I'll use that as a funny example, then what is it that I care about in an IoT toaster? Well, I probably care about the software, right? The embedded operating system, I probably care about the firmware and the device drivers that, make this thing communicate to the outside world. I probably care about the services that thing actually communicates with. And then, of course, the application and the libraries that kind of power the user interface and the user experience. That would be a complete inventory, in my opinion. And if you wanted to optionally, you could also represent hardware in there. So this is what I think a complete inventory kind of looks like. So looking at it again from a much more holistic perspective, I don't know how many SCA tools, for example, could identify an entire operating system, right? You'd be able to identify small bits and parts of it. You'd be able to identify maybe packages within the operating system, but that's not really what SCA is designed to do. But we can still create an accurate inventory and analyze that. And we'll talk about how we're going to be able to do that in software bill of materials. Now, there's some very strong opinions on hardware in this supply chain space. On one side of the fence, you have people that, are fairly religious on, let's just keep it only software and maybe services. And then on the other side of the fence, you've got some people in the, especially in the IoT and ICS space that really need to represent hardware as well in the combined inventory. That's why I have the question mark here. I think hardware is important, but if you have a need to be able to support that, I think you should. And if you don't have a need to support that, then you can, rightfully ignore it. But the complete inventory is really about that thing that's delivered to the market. Now, component age, this is something that a lot of SCA products do today, right? How old is my component? I'm not going to talk about this a lot because I think we all kind of understand this concept. A lot of the higher assurance environments that I've seen typically have open source policies, for example, that prohibit use of components anywhere between 3 and 5 years, right? If a component is older than 3 to 5 years, you typically violate their open source policy, and you need to get exceptions to use that component. Pretty self-explanatory. A lot of SCA products have this capability today. Again, many SCA products also can determine whether or not a component is out of date or not. And this is not only just a good practice, but it also has some security implications, and we'll talk a little bit about that. Components that are, a few minor versions behind, you may or may not have security implications. One of the major reasons, however, that we really want to encourage organizations to keep up to date with their components is the inevitable the inevitability of having to respond to an incident on an affected component. So if I'm a few major versions behind of a component, I probably can't just recompile with that major version update and expect everything to work. It's a major version because there's typically API incompatibilities between the versions, right? So when my component that's out of date by several major versions is affected by a vulnerability, I need to be able to quickly respond to that. And if I've been keeping my component up to date the entire process, well, then I can probably just recompile, redeploy, and I'm done. Whereas if I haven't been keeping it up to date, then I might actually have to rewrite some code to, quickly as possible anyway, bring that up to date. So my ability to respond to a security incident is, going from minutes to hours, days, or weeks, depending on the amount of refactoring that might be required. So anyway, this is a capability that most SCA products have today. And then, of course, there's things like Dependabot, as well as others that will help you keep your components up to date. Just a matter, of course, of good software engineering. Known vulnerabilities. This is also a very common SCA case. I don't think I need to explain this a whole lot. This is A9, and then of course I don't even know what number it is in the OWASP Top 10 2021. I'll have to look. Maybe somebody can put that in the chat. Component type. Oh, that's interesting. What does this refer to? This is really referring to, if you refer to that slide that was talking about operating systems or firmware, libraries and frameworks, that's really what we mean by the type of component. And the type of component is interesting because libraries typically will have different ways that they are integrated with a code base as opposed to frameworks, right? If I'm a few major versions behind on a framework, or if I need to swap out frameworks for another framework, well, I probably have to rewrite a large portion of my entire application, just because of the way frameworks are designed. Whereas if it's a library, even if it's used in a lot of places in my code base, I have a little bit different type of I have a little bit different, my development team would have a little bit different exercise in front of them if they had to update or replace that particular library. So architecturally coupling, for example, is kind of an important security aspect, especially when we need to upgrade or replace components. But component type also is interesting for containers or operating systems or firmware. So being able to classify these things in a higher level taxonomy is something that we all should be thinking about. Component function. This is really going down that taxonomy rabbit hole a little bit further in talking about what are the capabilities that this thing has, right? Is this thing a JSON parser? Is it an XML parser? Is it a persistence library? If it's I'll say XML parser. If it's an XML parser, well, that's interesting information because I already know that I have existing XML parsers in my code base. Why do I need another one? Right? It's an interesting question. Same thing with JSON. There's a number of different libraries available to parse, validate, sign, encrypt JSON. And knowing what the capabilities of all the components are can help you reduce your attack surface. Now, when combined with the inventory aspect, we talked about initially about the complete and accurate inventory. When you start identifying the function of a component and you are realizing that, hey, I've got 3 different logging frameworks and 5 different XML parsers and 7 different JSON parsers. When you combine both the complete and accurate inventory and the component function, you can start making some very basic Deming principle improvements. So Deming was a visionary in in a lot of areas, but specifically in supply chain, a lot of the work that he did with Toyota. And there's some basic principles at work here. Number 1 is using fewer and better suppliers. So instead of using 5 XML parsers, maybe I'll just choose the best one, which leads to, once I have a fewer and better suppliers, using the best quality components from those suppliers. And third is tracking that across my entire portfolio. So knowing where in my entire enterprise of first-party and third-party components I'm actually using this thing. So that's some basic Deming principles. So you can combine component function and the complete accurate inventory so that you can make some better, you can reduce your attack surface, but you also reduce the effort placed on development teams to actually keep these things up to date and maintain good component hygiene. So it's a cost saving and quality indicator as well. Quantity, again, the number of components that an application has. The more components you have, obviously, the more time your development teams actually have to spend maintaining these things. And if you have teams with time box constraints, then the more components you have, the less time they actually have to fix every single one of them, right? So the fewer components that we have, the less cost is actually involved, which is especially important for teams that might have time box constraints. Now, at one point in time, I don't know if it's still available or not, but at one point in time, Sonatype actually had a calculator on, I don't know if it was on their public website or if it was somewhere else, but they had a calculator that let you estimate the amount of cost based on the number of third-party components that you had in an application. So you could estimate that cost and how much cost it would be to maintain that amount of components for that application. And the calculator also scaled to the entire enterprise. So if you had one application or 5,000 applications, you can kind of estimate that cost across your entire enterprise. Repository trust. This is something SCA tools don't do. And what does it mean? And what exactly is a repository? Repository could be a couple of different things, right? It could be things like GitHub Enterprise, GitHub, or GitLab, where my version control is stored. It could be referring to things like Maven Central, NPM, and PyPI. So do we trust these repositories? And if so, how much do we trust them? This should also be some of the things that we care about. Maven Central, as an example, isn't, it doesn't have a lot of Maven Central, for example, doesn't necessarily do any one good security thing. Rather, they do a lot of little small things fairly well. And that defense in depth approach that Maven Central has makes it a little bit more trustworthy than some of the other repositories like NPM, for example. And I'm specifically referring to the fact that you need to prove ownership of the group IDs that you want to publish as, and you have to sign your artifacts when you publish them. These are basic requirements that that ecosystem has had for well over a decade that newer ecosystems just do not have today. So I think we need to, as a community, evaluate whether or not we trust these repositories. And if we don't, then what are we going to do about them? Do we create private repositories in our own enterprises and have vetted and pre-approved components within those repositories? Maybe we want to subscribe to private repositories, right? Which is a thing, right? There are competitors to NPM. There are competitors to Maven Central. Some of these are commercial, and some of them actually allow you to do static, or actually will require components to be statically analyzed and be vetted by a certifications team before they're actually made available to the rest of the subscribers of that particular service. So if you don't trust the public repositories, why not? And what are we going to do about them? And there's a lot of different ways that we can kind of increase the trust in our repositories. Again, this is not something that SCA solutions really care about today, but in the context of a global supply chain, this is absolutely critical if we want to have any kind of assurance of our supply chain at all. Provenance. Provenance is a couple of different things. Again, this is not something that most SCA solutions do today. But provenance can refer to a few different things, all of which we should care about. Number one is, where did we get this thing from? Provenance is really about the story of origin, right? And where did we retrieve something from? And that thing that we retrieved might be from a public repository like NPM, or PyPI, or Maven Central. It might be from a supplier like Oracle or Microsoft. It might be from a version control system. For example, if I'm using Go modules and I just reference a random URL, horrible practice, by the way. Or it might refer to a country of origin, right? I might have retrieved this from a community or an entity that might be in an adversarial country. So provenance can mean a lot of different things based on context, but it's all about the origin. Again, a capability that we should all care about. We should all care about where we got something from. When we refer to component analysis, this is kind of a core tenet of it. Pedigree. Pedigree is really about the DNA. So it's really talking about the ancestors, descendants, and variants of a component, and what changes, modifications, commits, diffs, what changes of a component that make this thing unique. So I am a descendant of somebody else, right? And we share a lot of common DNA, but there's certain parts of my DNA that make me unique. That same concept applies to software, whether it's a gradual, increase in versions of the same component, or whether we're referring to forking a component and tracking the changes in that particular fork. So pedigree is really about, identifying the ancestry, the lineage of my software or hardware in some cases, but tracking the lineage of my components, and also what the individual changes that make that component unique. Now, you can also lump formulation into pedigree, but it's really a distinct concept, although it's okay to kind of group these two related things together. Formulation is really referring to how something was built, how something was created. What is the, given a list of ingredients, right? What is the technical recipe that went into actually creating this thing? So when we refer to formulation, we're referring to what were the, how was the build system invoked? What were the properties of that build system? What were the parallel and sequential build steps that compiled and tested and delivered a given piece of software, right? So that's really what we're referring to when we refer to formulation. And this really has important security implications, especially for more native languages, where a compiler flag could be the difference between whether or not you're affected by a vulnerability or you're not affected by a vulnerability, right? Just that one compiler flag can sometimes tell you. But if you want to have assurance in your software supply chain, you need to start being able to think about documenting how I'm actually doing these things. Again, not an SCA capability, but in context of a global software supply chain and your own enterprise's supply chain, this is something that we all should really deeply care about. License. I don't think I need to really spend a lot of time on this. All SCA products, for the most part, do this today. Am I using a license that's approved, that's not approved? Copyright and whatnot can also be framed in this conversation, attestation reports, that sort of thing. But this is something that we should all care about. Inherited risk, and by inherited risk, I mean a couple of different things. The most obvious being, what are my direct and transitive dependencies, right? That transitive relationship that I'm pulling into my application, all that risk is inherited, right? But I also am referring to the inherited environmental risk of what it is that I'm actually delivering. Going back to that IoT toaster, there's a lot of components that make up that thing, right? My application relies on that operating, has a dependency on that operating system. My hardware has dependencies on maybe the firmware and the device drivers. And all these things kind of are interrelated, but risk is inherited. So I'm looking at the holistic view of risk for that particular thing, not necessarily specifically the direct and transitive relationships of things. So I'm taking a much broader approach in terms of risk. Project health. This is something that some SCA products are have some capabilities today. I know OpenSSF, for example, Linux Foundation, they've got the scorecard project, which hasn't necessarily proven value according to Sonatype yet. I know they're looking at it to improve the what they're actually measuring, so they can make a difference. But there's a lot of different ways that we can evaluate the health of a project, whether or not the maintainers are actually looking at defects and responding to the community. What's the release cadence, right?Ese types of things that we can take into consideration when we are evaluating the health of that particular project that produces the components that we rely on. And finally, external services. I don't know when the last time was. It probably was 15 years ago or more when I actually used a piece of software that was standalone, that didn't phone home to something for updates or talking to some external service on the interwebs. Modern software relies on other things, whether it's connectivity within your home or connectivity out to the internet. They all kind of, most software relies on something over the network. And being able to capture these things should absolutely be a critical part of that inventory. I actually view external services as merely a difference in serialization. So instead of calling a function locally, I'm calling a function as a service. It's really a matter of serialization. And in this case, it's just being serialized over the network. But external services should all be part of the inventory that we care about. And when we start to care about these services, we can start looking at the data and the data flow classifications and the directional flow of data between component and services. So again, something we should all care about in the global context of component analysis. So how does SBOMs kind of step up to be able to solve all of these things or answer some of these call to actions? Well, the Cyclone DX standard, which is a flagship OWASP project, was started in 2017. We had our first release in 2018. It's used by a very large percentage of adopters. We currently have estimates of upwards of 100,000 organizations that have adopted Cyclone DX today. So it's used quite extensively. We've got over, I think, 80 tools now that support Cyclone DX. So it's a lot of open source and a lot of commercial vendors support it. But Cyclone DX actually supports the majority of those use cases today. And the ones that it doesn't support formulation, for example, we actually have for roadmap items. In a sense, software bill of materials are at a very elementary level are a list of ingredients, but again, it does all these other things: provenance, pedigree, quantity, everything else. At a basic thing, though, it's just a list of ingredients, and this list of ingredients for, in this case, an energy bar, is so that we can make better risk-based decisions. If I'm allergic to nuts of any kind, this might be really important information for me. There's a lot of reasons, I guess, why software bill of materials are becoming at the forefront now. On the left here, and this is all data from Sonatype's 2021 State of the Software Supply Chain report. If you haven't seen this report, I highly encourage you to grab it. It's just full of really, really useful statistics. On the left, 73% year-over-year increase of components that we are using. No surprise there. We're producing more every single year. What is surprising, however, is this chart on the right. 650 year-over-year increase in the amount of supply chain attacks. So we're not necessarily caring about SCA anymore. I mean, the things that SCA does are important, but we need to look at the much broader picture. We need to look at repositories. We need to look at pedigree and provenance and all these other things, because 650% increase is a problem. The reality is that the attack surface of the global software supply chain is massive, and we have very little visibility at every single one of our organizations into what is our risk, right? I mean, yeah, we might know the vulnerabilities and the outdated and the license, but step back, and do we really know what do we really have assurance in our own respective software supply chains? I don't know. But it's a really massive attack surface. And quite frankly, there's a big opportunity for the adversaries to keep on taking advantage of this while we as an industry are still trying to figure things out. A lot of contributing factors for SBOMs, including basic supply chain management. These are the Deming principles that I mentioned earlier. There's market forces. Organizations that are able to produce SBOMs are much more mature in a lot of eyes. It's increasingly being used for procurement and mergers and acquisitions. It can help you identify cost. We talked about component quantity and all that. It can help you identify cost and cost savings. And then if you actually have SBOMs across your entire enterprise, you can very quickly identify what is affected and where in your environment you are affected. So if I have a vulnerable version of Apache Struts, and I've got 50,000 things in my enterprise, that have software, I can very quickly identify, oh, out of these 50,000 things, I have 12 that might be impacted by this Struts vulnerability. And I can do that within a matter of seconds, right? That's really what SBOMs can allow you to do. And finally, there's some regulations in the US. There's this Executive Order 14028 that requires SBOMs for procurement in the federal government. Now, this is a US-centric thing, but because of the pockets, because of the budget of the federal government, it has a large impact on the global software supply chain. So even if you don't necessarily sell directly to the federal government, you still might be impacted by this. So a lot of organizations are just preemptively just starting to adopt SBOMs just in case. It's a good engineering practice to begin with, but just in case they're called out on compliance for certain things, that you already have one. FDA already has pre-market. The Federal Food and Drug Administration in the U.S. has pre-market requirements for any kind of medical device, for example. And then there's critical infrastructure, energy, healthcare, et cetera, that also have requirements. This is really a look at what the object model of Cyclone DX looks like. There's a huge focus on simplicity. It's highly optimized to be automatable, not just in the creation of the SBOM. That's actually easy, right? Any format can do that. It's really optimized for large and complex pipelines, where you might have sometimes thousands of components being built from different things, and you end up with this really large pipeline that spits out some artifacts at the end, as well as some SBOMs. So it's really optimized for those types of use cases, so that we can augment and enhance and correct the SBOMs throughout the course of the entire build process. And then, of course, it supports a lot of different types of components. We talked about these earlier on with the complete and accurate inventory. I'm going to leave you with this link to some of the use cases that CycloneDX supports today. There's a number of use cases. They're all really interesting, starting with the inventory and all the way down through external services. But I highly encourage you, if you haven't already, take a look at this and kind of read through there. There's examples in both XML and JSON. The spec also supports protobuf. So if you want to do highly efficient machine-to-machine communication of Cyclone, you can do that with protobuf instead of having to rely on XML or JSON. But the examples on this website are specific to XML and JSON. Now, interesting on the site is that the examples are XML first. JSON, you actually have to click on the tab. The reason why we do that is that JSON has a lot of limitations, one of which is the inability to have comments. So we actually have comments in a lot of our XML examples, so that you actually are seeing why something is there, because you'll have a comment on why something is there. And then you can just flip over to the JSON example. Now that you actually know why something is there, you can flip over to the JSON example and see it in JSON representation. The spec also has the CycloneDX Tool Center. This is, I think we're above, I think we've got like 84, 85 different tools today, something like that, that supports CycloneDX. And these are just the tools that we know about. We're discovering more tools every single day. So it's a pretty big ecosystem of both open source and commercial vendors and services that support CycloneDX today. These are some links to kind of get you started with CycloneDX. When combined with Dependency Track, which is another flagship OWASP project, as well as some other things from some of these other vendors, like you'll see in the Tool Center here, you can start looking at your supply chain from a much more holistic view. So SCA products, many of them can create SBOMs today. Grammatech, for example, Sonatype Nexus IQ, for example. There's a few others that can produce SBOMs today. But we also have the ability to do an SBOM first approach by integrating it into our build environments and or that sort of thing. So there's a lot of different ways that you can kind of come to the SBOM approach. The idea, however, is to be able to view components from a much more holistic view and use a wider spectrum of tools and process improvements to really look at our software supply chain and start analyzing the risk of that. One thing that I neglected to put in the slide, however, is the OWASP Software Component Verification Standard, or SCVS. SCVS is a way for organizations to measure and improve their software supply chain. It is not a flagship project. It's currently an incubator project that is up for review. I'm part of the project committee, but obviously for obvious reasons, I'm not going to be voting on my own project. But we're trying to get that to lab and eventually flagship. But it's already being referenced in the NIST SSDF version 1.1 draft, so it's already a highly visible project, even though it's currently incubator. But I highly encourage you to check that project out as well, because it does look at the broader software supply chain aspect rather than just what we've been focused on for the last decade, which is really just SCA. So highly encourage you to check out SCVS as well. So with that, I thank you. I so wish I was there in person to meet all of you, but at this point, I'm going to open it up for questions and discussions.
Thank you, Steve. While we have a sudden delay for the YouTube and waiting for the questions to come in, let me start with the first obvious one. I think it's very interesting to have such insights in your software stack in all the dependencies. But I can imagine for a smaller or medium business or a small company with a large legacy and software, it's kind of a steep hill that you have to climb to actually get the full inventory and have that oversight. Have you some practical advice how to start, or what would be the first steps to do, and what is the time investment that a company should do to start actually building such a SBOM?
Yeah, I don't think the size of the company matters as much as the technology stack. I find that more modern stacks, things that use package managers, for example, it's much easier to just build on top of these existing foundations. So if you're using NPM or Python or Ruby, Rust, anything that has a package manager, Java, it's quite elementary to create an SBOM. So it's very little effort because it can be very easily automated. What is much more difficult are some of the more antiquated ecosystems, C and C++, for example, which is really heavily in the embedded space, right? Unfortunately, a lot of their best practices are still antiquated, even though package managers and stuff have been available for C and C++ for well over a decade. They're not widely used. So there's a lot of, legacy ecosystems that it's much harder to do SBOMs for. What's easier on some of the legacy ecosystems is SBOMs on source files. That's easy. That's basically just creating an inventory of all the source files, their hashes, etc. What's much more difficult, however, is taking unmanaged code that you have obtained from random places on the internet and trying to manually track all of that pedigree and provenance, because in most cases you really don't know. So for more modern ecosystems, however, and better development practices, I don't think the size of the organization really matters that much. It's fairly elementary.
So that's actually good news that for the modern frameworks, for the modern technologies, it's actually easier to start. Are there any significant differences in, if you see the dependencies, for instance, Python versus Java versus others, Maven, you named a few, where certain software stacks are more vulnerable, or that the libraries are less or more prone to errors or mistakes, or actually more getting critical vulnerabilities into the software, or is it almost the same over all the technologies?
I don't know. That's an interesting question. One thing that is kind of obvious is how the different ecosystems actually work when you're distributing something. So, for example, in Java, Java doesn't have it could, but culturally, Java is more of a macro library ecosystem, right? Where you have libraries like Apache Commons IO that, it's focused on IO, but it does a lot of different things. And I might only use a small fraction of that library. Whereas in NPM, you have more of the micro module approach. I might have a module that it has like 5 lines of code and it's used by 1 billion packages on the internet. And so there's some differences there. With regard to packaging, however, if you look at like Maven versus Webpack, which is also really interesting, it's very common in the Java ecosystem to ship a jar or a war that contains unused dependencies. You actually have to go through additional processes to kind of strip that out. Whereas if I'm developing a front end with JavaScript and I typically go through React or Vue, whatever, with Webpack, all the unused things are automatically stripped out. So my SBOM is really much more representative of reality versus my one over in Java that I might actually have to start removing some components from because I might not be including them. So there's some differences like that. In terms of code quality, I don't have any metrics on any of that, but there's certainly differences in the trust of the various repositories. Obviously, NPM is kind of NPM is NPM. There's a certain amount of risk that NPM has that other ecosystems do not have. Dependency confusion, namespace confusion. These were really elementary attacks on NPM, much more difficult to take advantage of, not impossible, but much more difficult to take advantage of in ecosystems such as Maven, which you actually have to prove that you have rights over the namespace in order to be able to publish as that namespace. So it's harder to do some of these attacks over in different ecosystems.
You already mentioned the provenance or certain parts of code that are being copy pasted into projects. I all of a sudden think about all kind of Stack Overflow copy paste actions that people are doing. What would be an approach to actually being able to try to link that or to actually try to add some provenance on those parts? Is it just finding URLs in source code? Is it really matching with certain known repositories of code fragments, or how would they actually have to imagine how to deal with that?
Yeah, Stack Overflow. Every organization, I think, has this problem. You find developers are stumped. They search, they find a solution, copy, paste, done, it works, and they move on. And given the constraints that developers are under, I don't blame them for doing that. But it does represent a certain amount of risk, right? There's good news. There are commercial tools. I don't know of any open source tools. There might be, but there are multiple commercial tools that will look for code snippets, so blocks of code, and finding out whether or not it might have been plagiarized or came from somewhere else on the internet. So commercial tools are available for that. And when you integrate that into your pipeline, obviously this is a much more advanced use case, but you can absolutely integrate that into your pipeline and describe that kind of that kind of pedigree in your SBOM. So it's again, it's not necessarily an SCA use case. It's more of an advanced SBOM use case, but it does have in some cases some security implications. You might have a snippet of code that might be affecting a library, and that vulnerable piece of snippet you've copied from Stack Overflow, or you've copied from a project, which was then copied to somebody posted on Stack Overflow. You found it on Stack Overflow, so now this vulnerable thing whose vulnerable code was copied to Stack Overflow, who you copied your code from, now your component is also vulnerable, but you may not necessarily have any insight into that. There's also obvious license and copyright implications to that as well. I think most of the tools in this space, the commercial tools that do snippet analysis, mostly focus on the intellectual property and license use case, but it also has absolutely a security implication as well.
Okay, that makes sense. Maybe a complete different question. You're involved in 3 projects, you're leading 3 projects within OWASP. Is there any of the projects a certain expertise or certain help from the community that you would like to have, or certain contributions that you would require? Might also be good to spell that out as well to the broader community here.
I gladly accept pull requests for anything. All joking aside, it's a lot of, if you've ever managed a project, let alone a flagship OWASP project, it's a lot of work. It's almost it could very easily be a full-time job for somebody, let alone managing multiples. So Cyclone DX, we are, we've grown. We've got a core working group. Cyclone DX is interesting because it's unlike any other OWASP project. It's basically its own foundation without necessarily being a legal formation as such. We operate as a meritocracy, similar to the Apache Foundation. We have different working groups. We have a formal standardization process and a formal governance process. So it's very unlike most OWASP projects, but the project itself has, I think, in excess of 40 repositories on GitHub. So we're involved in a lot of different things. We support a lot of different ecosystems, and we touch a lot of different types of software. So there's certainly, not a shortage of things to help with. So if you're interested in software bill of materials, we have our own dedicated Slack workspace independent of OWASP. I think we have like over 20 channels, for example. If you go to cyclonedx.org/Slack/invite, you'll get the invite for that. But we have 20 plus channels over there. There's the OWASP software component verification standard. I highly encourage everyone to kind of get involved with that. Try to adopt it within your organization. And if you run across issues, things that don't make sense, I think that's room for improvement. And community feedback is highly encouraged. And then, of course, there's the OWASP dependency track project. Right now, I think we're in excess of 4 million Docker pulls between all the various different things that we have or supported historically, used by well over 100,000 organizations today. And that project itself, just because it's more of an enterprisey type of thing, we're not necessarily targeting the individual developers. So that project has a lot of room for community participation. So if you would like to get involved with SBOMs and being able to analyze those with dependency track, I'd highly encourage you to get involved with that. There's a lot of enhancements, and I think there's a handful of defects that are kind of in the backlog. And pull requests are highly encouraged.
Thank you, Steve. You brought a lot of useful information today. You brought us an introduction to certain of the topics in SBOM here. And I really see the passionate way you're actually acting with this material. So I'm really glad that you were present today in our virtual OWASP meeting. I would like to thank you once more for actually doing the nice presentation. And I wish you all the best with the upcoming seasons for your OWASP projects. Thank you very much.
Thank you so much. And thank you so much for the invite. Cheers, everyone. I can't wait till I can get back to Belgium again.
We sure like to see you here. Thank you very much.
Indeed.
Sure.